All right, let's see. This is the Chapter 1 quiz solution. All right, which of these is a reason that a standard of measurement is not appropriate? All right, if either this is true or this is true, then that standard is not a good standard of measurement. If it changes or it's not accessible, so that is E. Doesn't really matter if it's based on some obscure physical constant. And in fact, most of the standards are based on an obscure physical constant. And of course, the smell doesn't really matter either. Is this equation dimensionally correct? All right, this is a little tricky, so I'm going to put in my units for each of these. X is in meters, A is in meters per second squared, M is in kilograms, and T is seconds, so that's 1 over seconds. So that's the left-hand side, and then the right-hand side, M is in kilograms, V is in meters per second, but it's squared, so it's meters squared per second squared. A is in meters per second squared, and then V is meters per second, but it's inverted right here, so it's actually going to be seconds over meters. And then I want to simplify these two. See, up here I get meter squared kilogram over seconds cubed. And over here I can cancel some of these things, and I get kilogram meters squared over seconds cubed. It's like those are the same, so the answer is A. Which answer has the appropriate sig figs in this operation? All right, I want to take this in two steps. First, I do this part. That's 1.0 times 0.01. That's going to be just equal to 1 over 3.4. It's 1 because I keep the lowest number of sig figs, and this value had the lowest number of sig figs. It just had one significant figure, whereas this number had 2 sig figs, but I keep the lowest number. And then 1 divided by 3.4, or excuse me, not 1, 0.01 divided by 3.4. When I divide that, I keep one significant figure because this number only has one significant figure, and so that answer is A. What is the area of the projection screen in the front of this room? All right, well, you don't really have a projection screen in the front of your room, but let's say, a screen is approximately 10 by 10 feet. So that's going to be 3 meters roughly by 3 meters. And that's going to give me 9 square meters. So it's going to be A. Now you might say, well, a screen isn't really 3 meters across. Even that's a pretty big screen. It is a decent sized screen, but it's definitely not a 1 meter screen. So a 1 square meter screen would just be 3 feet by 3 feet. It would be 1 meter by 1 meter, and that's itty bitty. That doesn't really make any sense. And a 100 square meter screen would be 10 meters by 10 meters. That's a 30 foot by 30 foot screen. So that's really huge. That doesn't really make any sense. So it has to be B. B is the most reasonable answer. All right, consider this figure. What is R? All right, so we have a triangle given the coordinates. This is the triangle right here. I'm going to draw it again over here, so we're just blowing it up. And I have 3.5 on this side and 2.5 on this side. And I want to know what is the hypotenuse of this right triangle. And so I say the square root of 3.5 squared plus 2.5 squared. Doesn't matter about the signs because you're squaring it. I get 4.3. So that's B is the right answer. All right, now I want to know what is the angle theta. Now look at the figure carefully because I want to know what is this angle theta. I'm going to blow up this triangle again. This side is 3.5. This side is 2.5. First, I'm going to find this angle. I'll call it phi. We'll do the tangent of the angle phi is equal to opposite over adjacent. Remember TOA, 2.5 over 3.5. Notice I just left the signs off because I know that I am looking In this case, in particular, for this angle, so you know the negatives don't really matter to me, and I recommend that you do it that way because it prevents any errors. And I get 36 degrees. Remember, that is this angle is 36, but I want to know the angle from the positive x-axis. I know that this angle is 180, so I want to do 180 plus 36, which is 216 degrees. So the answer for that one is C. If the displacement of an object x is related to velocity v according to this relationship, the constant a has the dimension of which of the following? All right, so this is a dimensional analysis. I have x equals a v. That's meters equals some units of a that I don't know, meters per second. In order to make these two equivalent, that should have units of seconds, because that cancels out the seconds and makes meters on both sides. Those are the same as the units of time, so the appropriate answer for that one is C. A crate has these dimensions. If there are 3.28 feet per meter, then what is the volume of the crate in cubic feet? Well, let's first find the volume, which is length times width times height, in meters, in cubic meters. That's 1 times 1.2 times 0.80. That's 0.96, keeping 2 sig figs, which is appropriate. That's in meters cubed. And now I want to convert that into cubic feet. So I say 0.96 cubic meters. And there are 3.28 feet per meter. But look, I have to cube this to make those cubic meters cancel and to give me cubic feet. So 0.96 times 3.28 cubed, that is equal to 34 cubic feet. That's A. A jet airplane climbs at an angle of 15 degrees with respect to the horizontal and follows a straight line path for 400 meters. You want to says that it travels 400 meters, so that distance is 400 meters, and this is 15 degrees, and I want to know how much altitude does it gain. So I want to know what is y. I'm going to use the sine of the angle. That's really the only one that you can use here. Think about your trigonometric functions. The sine of 15, let's see, that's SOHCAHTOA, S-O-H. That's opposite over adjacent. That's y over 400. So y is equal to 400 times sine of 15. Which is 104, but keeping proper sig fig should be just 100 meters. So that is A for that question. Mass, along with what other two quantities make up the three basic quantities in mechanics used by physicists? That would be mass, length, and time. So C is the right answer. Note the following mathematical expression. Which of the statements below is most consistent with this expression? All right, so if y is equal to x squared, if I double y, then x does not quadruple. If y is greater than x, maybe, but not necessarily. Like if x is less than 1, then that won't be true. If x doubles, then y doubles. That is not true. If x doubles, then y quadruples. That is true. So consider I have y equals x squared. Let's say that x is 2. 2 squared equals 4. But then let's say that x is equal to 4. 4 squared is equal to 16. So you see, when I double x, it quadruples y. You might want to think about this in this way as well. Y is equal to x squared. If I double x, this 2 is squared, then that means that it quadruples y. We'll have lots of relational problems like that, mathematical relationships that you'll have to deal with and interpret in that way. So if you have trouble with that, then please come see me because it's going to come up throughout the semester. All right, which of the following formulas is dimensionally consistent with an expression which would yield a value for inverse time, that's 1 over seconds. All right, so I'm looking for something with 1 over seconds. I'm just going to take each of these. I have meters per second times 1 over meters. The meters cancel. Oh, looks like it must be A. All right, let's go ahead and look at the rest of these, though. V squared over x, that's meters per second squared over x, so that's 1 over meters. So one of those meters cancel and leave me meter per second squared. So B is not the right answer. Let's look at C. Let's say this was B, A. X over T is meters per second. That's not 1 over seconds. And D is V squared T. That's meters over second. Both of them are squared times second. So that gives me meters squared per second. So that's not it either. So it has to be A. Since 1967, the standard definition for the second of time is based on the frequency of the cesium atom. The standard meter has been determined based on the distance that light travels in that amount of time. That's 3 times 10 to the 8th is the speed of light. Which of these is dimensionally consistent for acceleration? Acceleration is meters per second squared. So I'm just looking for one of these that gives me meters per second squared. Let's just take one by one. It's meters per second times 1 over second squared. That's meters per second cubed, so that's not it. B is meters per second over x squared. That's 1 over meters squared. That's 1 over meters seconds. That's not it. C is v squared over t, meters per second times 1 over seconds. That's meters squared per seconds cubed. All right, so hopefully it's this last one. V squared over x, that's meters over seconds. V is squared, though, times 1 over meters. So one of my meters cancel. I'm left with meters per second squared. So the answer is D for this one. What point is nearest the y-axis? Think about your Cartesian coordinate system. The point that is nearest the y-axis is going to be the point with the smallest x value. All right? So we want to look for that point that has the lowest value of x. These are x coordinates, and I just look for that. That's going to be -2, -5. By the way, that is going to be, if I were to plot this out, 1, 2, 1, 2, 3, 4, 5, that would be down here. -2 in the x, -5 in the y. Which of these represents the preferred practice for Sig Figs? Multiplying, you keep the lowest number of significant figures. Looks like this number has the lowest number, that's 2, and this result has 2 Sig Figs, so that's the right answer. The speed of a boat is given in knots. If it were in the SI system of units, it would be in meters per second. That's SI units, meters per second. If A has acceleration, V is velocity, and X is position, and T is time, then which equation is not dimensionally correct? So I just want to test each of these. A is seconds equals meters and over V. So it's going to be seconds over meters. The meters cancel, so that is correct. B is meters per second squared equals meters per second. That's squared, that's V squared over X, that's 1 over meters. So that cancels with one of those. That one checks out. Both of those check out. C is V meters per second equals meters per second squared times 1 over seconds. That's meters per second cubed on the right-hand side, meters per second on the left-hand side. So that is not right. So C is the right answer. Let's just go ahead and do D. I have seconds squared on the left-hand side. Remember, you don't deal with the 2. That's just a constant. So I have meters. And then 1 over A is seconds squared over meters. Well, that one looks correct, too. Oh, yes, of course. It is correct. So that one, D, is correct. So C is the right answer. C is the only one that's not correct. All right, which of these is a preferred practice for Sig Figs? I'm adding, so I keep the lowest number of decimal places. This one has 0 decimal places, so D is our right answer. It also just happens to have the lowest number of sig figs, but that's not relevant. Like, for example, if instead of being 15, this was just 5, then the answer would still be, what would that be? 48. You'd keep 0 decimal places, all right? So when you're adding numbers, you keep the lowest number of decimal places.